Suppose that I told you here 3x minus 4y equals negative 5. And I got over here 2x plus 2y equals 6. Suppose I gave you this system of equations. Now let's discuss this for a moment. Now, this may not be a very difficult problem to solve by substitution. If you decided to solve for one of the variables the way that we did on the last example after Omar suggested that we try that here. But what makes this problem a little harder to do than that one? The coefficients of x and y, if you look for them, none of them have a 1 in front of it. It turns out this particular one here has all even numbers, so you may notice, oh, that would give me a nice equation to use substitution. But let's just say we want to move away. We want to move away from substitution for a moment. Could we use the addition method as the equations are given to us right now? Well, let's see. If I added these equations, don't write this on your paper. I just want to show you what we have. Would there be any point, any advantage in adding the equations the way we did in the previous 3 examples? 3x plus 2x? 5x. Negative 4y plus 2y? What is it?
Negative 2y.
And 1. Did any of the variables cancel out? No. So I have an equation here that didn't really do much for us as far as getting one of the variables to disappear. So we're going to use one more property of equations that we've used before. I'm just going to remind you when we've used it by way of example here, and then we'll apply it to this idea. You guys remember what to do when you have an equation like this? X divided by 5 is equal to 3. When I ask you, if I ask you to solve that equation, what would you do? You multiply both sides of the equation by 5 in this case. Why? Because that's going to cancel the 5, but what matters here is that you know your equation is going to remain balanced because whatever you do on one side, you do on the other. You already know that when you multiply an equation by the same number, the equation that you end up with is equivalent to the original. It's valid. So let's apply that idea right here and think to yourself, ask yourself the following question. What can I do to either or both of these equations so that I end up with opposite coefficients in one of these variables? I would like to have things like positive 3 and negative 3 because they cancel out, or have a negative 2 and a positive 2 because they cancel out. As you look at these equations, think about, can I multiply one of these equations by something so that I would end up with opposite coefficients in one of the variables?
For all the numbers?
Not all, just one right now. Let's say, for instance, if I wanted to have opposite numbers here, I cannot see an easy way of multiplying 2 by some whole number that will give me the opposite of 3. I cannot change 2 into a negative 3 easily. I would have to multiply by a fraction. Bad idea. So I don't want to change this one. This one's here. What is the opposite of negative 4? Positive 4. Could I multiply this by something so that it'll change into a positive 4?
2.
Yes, I could multiply by 2. And that's going to be the challenge in the addition method. That you're going to have to look at the coefficients and make a decision. I can multiply by anything I want. But your job is to select a number that you can multiply one of the equations, or both, as I'll show you in just a moment, so that one of your variables will disappear. So once again, I've decided I'm going to cancel the y's. Why? Because I can change this number into the opposite of this number. That was my decision. Okay? And that's something that you have to get comfortable at doing, and this is the most challenging part in this addition method. Getting enough practice for you to feel comfortable saying, oh, I know. I can change this one into the opposite of this number by multiplying by What did you say?
2.
By 2. Just remember though, everything in the equation has to be multiplied by 2. So many of my students in the beginning want to say, well, I just want to change this number. They multiply this by 2 and they forget everything else. You can't do that in an equation. So let's see what we get. I'm going to just write it right next to it. What we get when we multiply that second equation by positive 2. Do it please and write it down. The first equation you get to just copy. So what did you write for your second equation? 4x plus 4y equals 12. Now notice, right, all I've done is change one equation by multiplying the whole thing, by the whole equation by 2. And as long as you do that, you can multiply by anything you like. The challenge is picking this number right here. You get to pick that number. You have to make that choice. You have to decide which equation you're going to multiply by something, and you got to decide what is the number you're going to multiply it by. In this case, first equation stayed the same. My second equation changed a little because I multiply all the way by 2 with what? What was the objective? Remind me, why did we do that?
To
cancel out the y's. As you can see now, the coefficients are opposites of each other, so let's cancel what we can. So 3x plus 4x? 7x. The y's cancel out. And on the other side we have negative 5 plus 12.
7.
All right. 7x equals 7. You divide by 7 both sides of the equation. And you write x equals 1. Are we done?
No.
And we're done with x. So here's x. Now plug it in. Now you have 4 choices. Actually 3 choices. You can take this x, plug it in here, plug it in here, here or here. It makes absolutely no difference. Pick one and plug it in and then solve for y. I'm going to give you a minute to do that. Cynthia, which equation did you select? The first, the second, the third, or the fourth? The first equation. So I'm going to take Cynthia's suggestion. I'm going to plug in my value of x into this equation. Did anyone choose a different equation? Which one?
The fourth.
The fourth? Very nice. So what I'd like us to do is you stick with that one. I'll do the first. And if we do things right, both y's should be the same, no matter what equation you select. So if I pick the first equation, the problem that I have now is 3 times 1 minus 4y equals negative 5. All right, I need to solve this equation for y. And I say 3 times 1 is 3 minus 4y equals negative 5. Subtract 3 from both sides of the equation. The 3's cancel out. What am I left with? Negative 4y equals negative 5 and negative 3 is negative 8. And last, we divide by negative 4. Y equals what? Is that negative? You've got 2 negatives, so that would be positive 2. Again, we have a solution, which is the 0.12.